So, um, so for our lesson, both of the warm-up questions are going to be helpful in what we're talking about. And so, getting you guys thinking about some things you probably forgot about. And I heard Dakota was talking about a little trick that Mr. Hatfield had used maybe with you guys last year with Algebra 2. It was like a goofy meme that I found a few years ago. And he, of course, because it's a little diabolical, he of course loved it. So, let's see if you guys remember that. All right. So, hopefully the first one you remember. If you didn't, you're going to kind of be like, oh yeah, that was kind of obvious. That function notation is just a little bit of a strange notation that we don't use as often, like in the lower levels, but as we get further up in math, the function notation, f of -3, kind of becomes a little more second nature. My algebra kids just saw this for the first time this chapter. So that f of -3, what's that telling me to do? Yeah, it's just a short way to say x is -3, and we're going to substitute that in. Now, just a quick reminder, when you're substituting in a negative, you want to be careful with your calculator. Make sure you don't let your calculator try to be too smart. When you square a negative, your calculator needs you to put that in with parentheses, most of your calculators anyway. So just be careful about that as you're doing this, because I don't want you to make a silly mistake there. Because -3 squared is actually +9, but your calculator might tell you it's -9 if you don't put the parentheses. So just be careful on that. That's another little trip up spot. And then we end up with, is it -8? Yeah. And you would have got a bigger negative number if you missed that negative, like the parentheses. All right. So I feel like the effort, or the mistakes on this has gone down significantly ever since you maybe learned the funny little meme that went with this. So, what do we need to do on a problem like this? What's our rule for this? Yeah, you have to write it twice. You cannot distribute that power in. If you distributed that power in, what was the joke that, what'd you just do? You killed a puppy. Do you guys remember that meme? Did you all see it? Yeah? No, I'll have to show it to you. Because yeah, if you didn't have, I'll pull it up. Let me see if I can find it quickly here. Sort of quickly. Oh, I'm my computer. The killing puppy meme, I found it a few years ago when I was at teaching at Cedarburg, and I got booed a few times with it, but you know. I actually love puppies, so. But it'll make you not want to. There's actually a whole website about different little things that you could do to and of course they pick like the cutest puppy ever, and he's like waving his paw at you. So every time you do this, you distribute that power in. A puppy dies, and the little puppy waving to you. And there's a whole bunch, there's a whole website of this. They kill bunnies and all sorts of things. So thinking about it, and hopefully you won't forget that as you guys are doing these. So let me pop this back over. So what we need to do, like Dakota said, we have to write it twice. Otherwise we kill a puppy. We don't want to do that. So, whoops, I just flipped that off there, and my battery's running low. It's all sorts of issues, of course, because I'm recording. I'll be okay. I just, yeah. All right. So we're going to write it twice. When we write it twice, then we have to do FOIL, double distribution, however you guys think about it, remembering to distribute. So we're doing 2 times 2, so we should have 4 terms, first, outer, inner, last, all those different like fun acronyms we have with this. And then we remember that we can combine like terms in the middle. Careful, those 2 negatives do not cancel. They're going to combine to be a negative 12, right? So we want to be careful as we do this, just that we don't forget those little steps like that's, and that distributing that power, and it makes you miss that middle term, which is obviously important. You know, like a whole term is kind of a big deal. So we want to make sure we have that, okay? So we're going to talk about composition of functions today. So we're going to be working with functions in this function notation form, so that f of x form, and it's kind of the easiest way to work with, like we're going to kind of combine functions together and manipulate them. It's going to be a lot of algebra today, so that might be a good thing. I'm assuming a lot of you guys here in pre-calc, you probably got through algebra with a lot of success. So I'm hoping that's the case for you. So we'll talk through some of these here. Yeah, I never know what I All right. So we're going to talk about 2 composition of functions today. And we're going to learn a notation that looks a little strange. So it's F-O-G, like, but not an O, it's actually supposed to be like a circle, like a little circle. Open circle there. This is the same thing, we'd write it like this. But for whatever reason, the math people decided that little f with the O-G, like F, it looks like F-O-G or fog, X. This is really saying f of g of x. So what this is telling me to do is this is telling me to put g inside of f. So we're putting one function inside of the other. So we're going to take an actual function, drop it in place of the other. And I'll show you kind of a smaller example with it here in a second. We can also do the opposite. G of f. So now this is just asking us to do the opposite. So I'll try to show this like on a smaller scale before we make it a more complicated problem. So, and I'm going to use different colors to kind of help hopefully here. So if I have f of x is 4x plus 5, and g of x, well actually let me use a different color. So I'm going to kind of start with some pretty basic algebra. The one on our paper is a little bit more complicated, so if you want to write this in the margin somewhere, if you just want to follow along, and I just realized I should probably move my video over here. Okay. So if they're asking me to do f of g, or f of g of x, they're saying in place of my x, I have to take this whole function and put it in there. So I'm going to take that function and drop it into the other one. So in place of x, I'm going to put the 2x minus 1. So it's telling you to put one function in for another. And then we would just do the algebra to simplify that. So this is just dropping into that one. So this is f of g of x. So then I would distribute. And then I would move, I just combine the like terms. So it'd be 8x plus 1. So that'd be f of g of x. They could also ask me to go the other way and do g of f of x, and so then I flip it. The ones I did on here are a little more complicated, so I thought I'd start with an easier one to begin with. So again, if I asked you to do then g of f of x, it would go the opposite way. So this whole thing would go in place of the x. And so you're going to get a different function when you do that. So I would take the 2 parentheses minus 1, and I would put the 4x plus 5 in there. So here we distribute, and so I get 8x plus. So I get something pretty similar, but obviously not the same. So we want to make sure we understand that one is different than the other. So what we're going to see that in our notes here is we're going to get a little more complicated, which is why we did the warm-up questions we did. So looking at this next one, it asks you to do 3 things for each of these problems. It asks you to do f of g of x, g of f of x, and then f of g of 3. So it's basically, there's like 3 parts of the problem if you look at the directions. So I'll break this like each problem into our 3 parts here. So we have to do f of g of x, then we're going to do g of f of x, and then kind of thinking back to the warm-up, we're going to do f of g of 3. So they're giving us a value for the x as well. And we're also going to simplify them as we go. So once you like put them in, kind of like we did on the board over there, we're going to simplify. So this first one's asking me, so the g's inside of f. So the g's dropped in there. So we're going to put g inside of f. So this is going to go inside of that x there. Like in place of the x. So you drop the x out and you're going to put the x minus 4 in. But in this case, the x is being raised to the 2nd power. So we're going to do x minus 4, but we have to raise it to the 2nd power because that's what was happening to x. And then we're going to add 1. So this is what that function looks like when I drop that g into f. But now we have to simplify as well. Are we okay with this step? Like, is that, like, so you're putting that in place, just replaces it, now we just have to simplify. And again, going back to our warm-up, we can't just distribute that second power in. We have to write it out twice, unless you can do a little bit of it in your head, that'd be great, just to save you a little bit of time. I'm hoping that's something that you don't get too freaked out over anymore. FOIL, like, there's all sorts of patterns that work there that hopefully you notice some of them. So I combined my like terms and I end up with just a quadratic, that simplified quadratic there. So again, a lot of algebra. Be okay? Let me know if you're stuck somewhere. Now the other way, now we're doing f of, or g of f of x. So now f is going into g. Usually one is easier than the other, especially when we have a power. So this one is actually easier. So you're gonna notice, you're gonna kind of be like, really, that's it? Like, I mean, so kind of we started with the more difficult one. So that x squared minus 1 is going to drop in place of the other x. So you take that x out and you replace it with x squared minus, or x squared plus 1. And that's our x, and then we just have to write minus 4s behind it. That's all that's happening to the x. So this one just becomes a very simple simplifying there. Not much I have to do there. And then what's the last one asking me to do? F of g of 3. What's that telling us to do? And it is really similar to the warm-up. Cool. Okay, so in the g of x problem, we make x 3. So we're putting 3 in here. 3 minus 4 is a negative 1. But then we have to put that into the other one. What would be the easy? Does anyone see like an easier step we could take than that? I mean, I don't think that's what. Unless I didn't hear your whole statement. I don't know. Does anyone see what else we can do? So essentially, I have f of g of x. Do you see that? And I just replaced x with 3. So where can I replace 3? In which problem?
The first one.
Yeah, we can just take that 3 and put it back into that first one. And I don't know if that's what you were getting at, but we can take that 3, and we already have f of g of x. That's right here. So they're just saying x is 3 in that big, complex, problem, that composition that we had. We can put that 3 in there. So I'm just going to take 3 and put it into this polynomial. And so just do the math then. And we end up with 2, I believe. Yeah. So f of g of 3 would just be 2. All right, the next problem is very similar. It is a little bit tougher, but I want to give you guys some time to try it. So why don't you guys try the next one. We're doing the same 3 steps with this next one for letter B. So you're basically doing the same 3 parts, there's like a part A, B, and C for each of these. So if you can try this next one, they give you 2 new functions to work with. And feel free to check with somebody or talk through it with somebody. You want me to check it before you go too far? So, you guys, okay, so this one real quick before you get too far, and maybe Dakota has gotten too far. Order of operations. What's more important? So you do parentheses first. Inside the parentheses, not anything you're gonna be able to do. What's next most important? Exponents. You should do the exponents before you multiply or divide. So you should be doing the exponents before you distribute that 6 in. Is that answering your question, Dakota? Yeah. So you should do the power first, yep. So do the FOIL there first, and then distribute that 6 in. So FOIL before you. Yes, now you're ready to.
So do I only put the 6 in the first?
I would FOIL it first and then distribute. I mean, but yes, you could. You could just distribute it into the 6 or the first one. Otherwise, you're like really distributing more than that. So like, you only want the 6 in front of one of them. Otherwise, now it's become like 36. So yeah, so now you'll FOIL. Yeah.
So
No, I would FOIL now. So like distribute, like do those two together, kind of like we did up here, and then distribute the 6 last. So you're just missing your 6 in the front. So the 6 there, and then down here, and now you're going to distribute that. Like so put that like that part in parentheses here. Oh no, like sorry, that whole column, like the x squared. Right, yeah. And then at the end, and then there's still this -4 on the end. Don't forget about that. But you're going to distribute, yeah. Okay, so you're close. So you want parentheses, like before the x squared, and then after this 4. Yep. And you'll combine all that together, and then you'll distribute the 6, and then you'll subtract. So yeah, order of operations. I mean, you guys, it's been a while since you've just done like algebra manipulation, so it's okay that we're a little bit. You're multiplying it by whatever was in here. So that's the x. So basically from here to here, there should be like parentheses. I'll get you guys going on if I can. Yeah, that looks good. All right, I'm gonna get you guys going on this tougher one. Or maybe once you guys try the second part, maybe that might be better to try first. The algebra is a little bit tricky. I guess I forget that it's been a while since you've done regular algebra.
yeah.
Yeah, well, that's
It's 6 times 4.
because one place you put 24 and the other place you put 16. I'm confused. You're probably not going to be able to do part 3 unless you have part A done correctly. So. I see a lot of you guys still writing, so I'm going to wait still. And if you want to wait for us as well, you're welcome to. But all right, are we ready? Okay, so I kind of forgot how many hangups we can get with this, and maybe my other class wasn't just being vocal about their confusion. We talked about it quickly, but so this is being distributed or putting in there. So I'm putting 6x plus 2 squared minus 4. Most of you guys were okay with this. So this is where we want to talk about PEMDAS. So inside the parentheses, there's currently nothing I can do. I can't do anything with the x plus 2. The next thing I should do is exponents. So that's where we have to write this twice, because essentially we're multiplying it by itself. But that step is still like the exponent step. You're still distributing that and doing that work. So when I go to like write this out twice, technically I'm still doing exponents here. Like that's what that math was, so I can't do anything else until I have this done. So some of you guys are trying to distribute right now, and that makes it way more complicated, I think. So I would stick to just trying to get this taken care of first. And again, I'm still gonna kind of do what's inside the parentheses. Try and finish that off. Now at this step, now I can multiply or divide before I add or subtract. So I did everything inside the parentheses I'm able to do. The exponents are essentially done. Now I'm going to distribute the 6 in. But then the -4 is just kind of hanging on the end, and then I just have to combine my like terms. And it's been a while. Like, I mean, you probably haven't done this really since last year. We haven't really done anything with just like manipulating a huge quadratic around. Like it's been a while. It's okay. Hopefully jogging your memory though, you'll be like, oh yeah, that was right. Yeah, I got that. Now, I probably should start the other way. This one's, hopefully you realize this one's a little bit easier, because this one, when I drop it in, I don't have to use the power. Like the power just is part of the problem. So 6x squared minus 4, and then just plus 2. So this one's almost so easy that you're like, really? That's it? Like, that's all I have to do? Hopefully if I didn't make, silly mistake, but yeah. And then the last one is asking us to put 3 into the f of g of x function, which is that red function down there. So now we're going to put 3 in there. And again, order of operations matter, so I have to use the power before I multiply, so 3 to the second is more important. So I'm going to do 9 there. And then what do you end up with? Is it like 146 or something? Yeah. So we multiply, and then we add and subtract, and 146 is our final. Okay. All right, questions there? Okay, so we're going to move to the back side, and we're going to talk about solving some more complex equations. I'm going to give you guys a little bit more time to look at this and talk through it. And look at these 3 equations. These are all equations we should have some idea on how to solve. We've solved them at one time or another, either this year or in past years. So some you might have remembered and some you might not. So take a minute to look at these 3, see what you guys know how to solve, and we'll talk about them today.